10th Science Chapter 11 Board Question Set 1 Mark 1. How is an ammeter connected to a circuit to measure current flowing through it? So the ammeter is connected in a circuit in series. What happens to the resistance of a conductor when its area of cross section is increased? So resistance decreases because the resistance is inversely proportional to the area of the cross section. Given length of a wire is double on itself and this process is repeated once, by what factor does the resistance of the wire changes? So length becomes 1/4 of the original length and area of cross section becomes 4 times that of original. That is L2 equals to 1 by 4, L1 and A2 equals to 4 A1. So R2 upon R1 equals to I2 upon I1 into A1 upon A2, that is ampere. On putting the values we get 1 upon 16. So resistance of the second is 1 upon 16 to resistance 1. Two resistors of 10 and Newton and 15 Newton are connected. 10 ohm and 15 ohm are connected in series to battery of 6 volt. How can the value of current passing through them be compared? So in series, same current flow through each resistor, so the ratio of current is 1:1. A wire of resistance 20N is bent to form a closed square. What is the resistance across a diagonal of the square? So resistance of each side of square equals to 20 by 4, which gives 5 ohm. So 1 upon Req equals to 1 by Rab plus Rbc plus 1 by Rag plus Rdc equals to 1 upon 5 plus 1 upon 10. So we get 1 upon 5. Why is a series arrangement not used after connecting domestic electrical appliance in a circuit? So it is not used because if one stops working due to some reason, the other will also stop working. There are two electrical bulbs, one marked 60 watt and 220 volt, and the second marked 100 watt and 220 volt. Which one of the following have a higher resistance? So the 60 watt bulb will have higher resistance because power equals to volt square upon resistance. So putting the value we get P is inversely proportional to 1 by 4. If four resistors of 1 ohm are connected in parallel, the effective resistance will be, if four resistors each of 1 ohm are connected in parallel, the effective resistance will be 0.5 ohm. A given conductor depend upon, so resistivity of a given conductor depend only on its material and the temperature. Resistivity does not depend on the dimension of the conductor. Define electric current. Time rate of flow of charge through any cross section of a conductor is called electric current. Ohm's law. According Ohm's law, temperature remains constant. The current passed through a conductor is directly proportional to the potential difference across its end. That is, V is directly proportional to I, or V equals to IR, where R is known as a constant, that is resistance. State the SI unit of current, electric current, and define it. An ampere, which is defined as the rate of flow of 1 coulomb of charge per second. In an electric circuit, state the relationship between direction of conventional current and the direction of flow of electron. In an electric circuit, the directional of conventional current is taken as opposite to the directional of flow of electron. Define potential difference. So, potential difference between 2 point A and B is an electric field is defined as the amount of work done in order to move a unit of charge from point B to point A. Thus, VA minus VB equals to VAB upon Q. What is meant by the statement potential difference between point A and point B in field of 1 volt? Amount of work done to bring 1 coulomb of charge from point B to point A with 1 joule of energy is called 1 volt of potential difference. When do we say that the potential difference between 2 points of a circuit is 1 volt? So potential difference between 2 points of an electric current is said to be 1 volt when a work done of 1 joule is to be done for moving a charge of 1 coulomb between these 2 points. What is the name of physical quantity which is equals to V upon I? So it's electrical resistance. Define resistance, give its SI unit. So resistance of a conductor is the measure of opposition offered by it for the flow of electrical charge through it. SI unit of resistance is ohm. When do you say that the resistance of a wire is 1 ohm? So resistance of a wire is said to be 1 ohm if for flow of 1 ampere current through the wire one has to maintain a potential difference of 1 volt across its end. The potential difference across the terminal of a cell is 1.5 volt. It is connected with a resistance of 30 ohm. Calculate the current flowing through the circuit. So current equals to I equals to potential difference upon resistance, which is equals to 1.5 V upon 30 ohm. Which material is the best electrical conductor? Silver. Electrical resistance of a conductor. The electrical resistance of a conductor is its property to oppose flow of electrical charge through it and is measured by the potential difference being applied across the conductor so as to maintain the flow of 1 ampere of current through it. What is the shape of VI graph for a metallic wire? So a straight inclined line passing through the origin, because for the metallic wire V is always direct because because V is directly proportional to I. The resistance of a resistor is kept constant and the potential difference across its two ends is decreased to half of its former value. State the change that will occur in the current flowing through it. So the current flowing through the conductor is reduced half of its previous value in accordance with the relation I equals to V upon R. Keeping the potential difference constant, the resistance of an electric circuit is double. State the change in the reading of an ammeter connected in a circuit. So the reading of ammeter is reduced to one half of its previous value because I equals to V upon R. The length of a wire is doubled and its cross-sectional area is also doubled. What is the change in its resistivity? There is no change because resistivity of material depends only on nature and is interdependent of its dimension. What is electrical resistivity? The electrical resistivity of a material is the resistance offered by a unit cube of that material between its opposite faces. On what factor does resistivity of a conductor depend? So resistance of a conductor is directionally proportional to its length and inversely proportional to its cross-section area and depends on the material of the conductor. Resistance also depends on the temperature. List the factor on which resistance of a conductor in the shape of a wire depend. So resistance of a conductor. How are two resistors with resistance 1 ohm and resistance 2 ohm are to be connected to a battery of EMF 3 volt to obtain maximum current flowing through it? So for maximum current flow, the net resistance of the circuit must be least possible. Hence, resistance 1 and resistance 2 should be connected in parallel. What is potential difference is needed to send a current of 5A through the electrical appliance having a resistor of 18 ohm. So potential difference equals to V equals to IRI, that is 18 into 5, we get 90 volt. You have two metallic wire of resistance 6 ohm and 3 ohm. How will you connect these wires to get the effective resistance of 2 ohm? In parallel, because then 1 upon R equals to 1 upon 6 plus 1 upon 3 equals to 1 by 2. Hence the resistance is 2 ohm. Voltmeter. Voltmeter is a measuring instrument used to measure potential difference between 2 points in an electrical circuit. What happens to the resistance of a conductor when the length of the conductor is reduced to half? So the resistance of the conductor is reduced to 1/2 of its previous value because resistance of conductor is directly proportional to length. What happens to a resistance of a conductor when its temperature is increased? So on increasing the temperature of the resistance of the given conductor also increase. Name the instrument device used to measure electric current in a circuit. An ammeter. How is an ammeter connected in a circuit to measure current flowing through it? So the ammeter is connected in series of the electrical current. Name the instrument used to measure electric current and potential difference. So electric current is measured by ammeter and potential difference is measured by voltmeter. In a circuit, if resistors of 5 ohm and 10 ohm are connected in series, compare the current passing through the two resistors. In series arrangement of resistors, same current flow through all the resistors. Two resistors of 30 ohm and 60 ohm are connected in parallel in an electric circuit. How does the current passing through the two resistors compare? In parallel arrangement, current flow through different resistors are in the inverse ratio of their resistance. Hence, current passed through 30 ohm resistor is double of current passing through 60 ohm resistor. Write the relationship between electric power in watt of the device. So power equals to potential difference into current. What is the heating effect of an electric current? When electric current is passed through a resistor, electrical energy is distributed in and appears as heat energy. This is known as heating effect of an electric current. How many joule are equal to kilowatt hour? So 3.6 into 10 की power 6 10 की power 6 joule is equals to 1 kilowatt. Out of 60 watt and 40 watt lamp, which one has higher electrical resistance when in use? So 40 watt lamp has a higher electrical resistance because R equals to V square upon P. Power of a lamp is 60 watt. Find the energy in SI unit consumed by it in 1 second. So energy consumed is PT, that is power into time. So 1 watt into 1 second equals to 1 joule. Out of the two, a toaster of 1 kilowatt and an electrical heater of 2 kilowatt, which has a higher and a greater resistance. So the toaster has a greater resistance because its power is less. Name any two applications devices based on heating effect of electrical current. So electric iron, electric toaster, electrical oven. Nichrome is used to make the element of an electric heater. Why? So nichrome is an alloy of high resistivity and high melting point and does not oxide. Joule's law of heating. As per Joule's law of heating, the heat produced in a resistor is H equals to I square R into T. How much current will an electric bulb draw from 222 volt source if the resistance of the bulb is 1200? If in place of a bulb a heater of resistance 100 ohm is connected to the source, the current drawn by it. Calculate the current drawn by it. So given V equals to 220 volt. So R1 equals to 1200 ohm and we have to find current of the first bulb. So using ohm law we get that volt equals I equals to V upon R. So putting the value we get the current passed through the bulb is 0.18 ampere, and same with second, putting the value we get the current passed through the heater is 2.2 ampere. A 9 ohm resistance is cut down into 3 equal parts and connected into parallel. Find the equivalent resistor of the combination. Resistance of each part equals to R by 3, that is 3 ohm. So resistance 1, resistance 2 and resistance 3 are equal in parallel combination. Putting the value we get that resistance of the combustion is 1 ohm. An electric iron has a rating of 750 watt, 220 volt. Calculate the current flowing through it. So the current flowing through it is by power. We get the by using the formula of power VI. So putting the value we get that 750 upon 220 equals to 3.40 ammeter ampere, that is the current passing through it, and its resistance when in use. So its resistance is 64.53 ohm. Charge possessed by an electron is 1.6 into 10 power 9 minus 19 the coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So we know that Q equals to I by into T. So Q equals to NA. So NA equals to current into time. So N equals to current into time upon electron. So 1 into 1 upon 1.6 into 10 power minus 19. Explain the role of fuse in series with an electrical appliance in an electric circuit. So fuse wire is a safety device connected in a series with the live wire of circuit. It has higher resistivity and low melting point. It melts when a sudden urge of large current pass through it and disconnect the entire circuit from the electrical supply, but in disconnected the entire circuit from the electrical supply. But in case if we use a large rating instead of a defined rating, hence then it will not protect the circuit as higher current will easily pass through it and it will not melt. The wattage of a bulb is effective wattage if it operates a 12-volt battery. Calculate its effective wattage if it operates on a 6-volt battery. So given P1 that is 24 watt and V1 that is 12 watt and P2 we have to find and V2 is given 6 volt. Using power formula we get power equals to V square upon R. So putting the value, so the wattage means the power used by the battery is 6 watt. Two metallic wire A and B of the same material are connected in parallel. While A has length L and radius R, wire B has a length 2L and a radius 2R. Calculate the ratio of the equivalent resistor in parallel combination and the resistance of wire A. For wire A, current 1 equals to I, that is R1 equals to R and P1 equals to P. So RA equals to P1 I1 upon A1. So wire B, I2 equals to 2I and R2 equals to 2R and P2 equals to P. So putting the value in parallel combination, we get the answer is 1:3 ratio. A piece of wire of resistance 20 ohm is drawn out so that its length increased to twice its original length. Calculate the resistance of the wire in the new situation. Using the formula R equals to power into current divided by A, putting the value we get the resistance of the wire is 80 ohm. An electrical lamp is marked 25 volt and 220 volt. It is used for 10 hours daily. Calculate its resistance while glowing. So resistance equals to V square by P, and so putting value 220 square by 25 we get 1936 ohm. Energy consumed equals to power into time. So putting the value we get the energy consumed by the lamp is 0.25 kilowatt first. Copper, as it has the less resistivity. Second, manganese, as it has the comparative higher resistivity, lacks oxidation even at higher temperature. Define electric current. An electric circuit comprising of a cell, a resistor, an ammeter, a voltmeter, and a closed switch. Distinguish between an open and a closed circuit. So a continuous and closed path of an electric current is called an electric circuit. An electric circuit shows a cell E, a resistor R, and an ammeter a voltmeter V, and a closed switch S. An electric circuit is said to be an open circuit when the switch is in off mode and no current flows in the circuit. The circuit is said to be a closed circuit when the switch is on in on mode and a current flow in the circuit. An electron each carry a charge minus E is flowing across a unit cross section of a metallic wire in a unit time east to west. Write the expression for the electric current and also give its direction of flow. So, first, electric current in a circuit is defined as the time rate of flow of electric charge through any cross section, and its direction is opposite to that of flow of electrons. Hence, in present case, electric current I equals to Q by T equals to Ne upon 1. As electrons are flowing from east to west, the direction of electric current is from west to east. Second, the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So here current I equals to 1 ampere, time equals to 1 second, and charge on each electron equals to 1.6 into 10 power minus 19 coulomb. Hence, number of electrons flowing through it is 6.25 into 10 power 18. Define the term volt. State the relation between work, change, and potential difference of an electric circuit. The term volt is the SI unit of potential difference. Potential difference is said to be 1 volt if 1 joule of work is done to carry 1 coulomb charge from one point to another. B. State the relation between work, charge, and potential difference. The relation between work, charge, and potential difference on an electric circuit is volt equals to W by Q, given that W equals to 100 joule and Q equals to 20 coulomb. So the potential difference equals to 5 volt. Mention any condition under which charge can move in a conductor. Name the device which is used to maintain this condition in an electric circuit. A current of 2A passes through a circuit in minutes. If potential difference between the term of the circuit is 3 watt, what is the work done in transferring the charge? So electric charge can move in a conductor when potential difference is managed across it, and an electric cell is used to maintain potential difference across the conductor and thus can be used for flow of charge. B. Here I equals to 2A, time equals to 1 minute, which is 60 seconds, and volt equals to 3 volt. So total charge flowing Q equals to I into T, which is equals to 120 coulomb. State Ohm law. How can it be verified experimentally? Does it hold good in all conditions? So George Simon Ohm established a relationship between the electric current flowing through a conductor and the potential difference across its end, due to which current flows. According to Ohm's law, temperature remains constant and current passed through a conductor is directly proportional to the potential difference across its end. So V is proportional to I, or V equals to I into R. Here, constant R is known as the resistance of given conductor. For a given conductor, its resistance is constant at a given temperature. XY is a resistance wire. An ammeter and a voltmeter, a battery of 4 cells is being used as a current source, and K is a plug key. Initially used only cell body. Put plug in K and note current and voltage by nothing ammeter and voltmeter reading respectively. Let those be I1 and V1. Then connect two cells in the circuit and note current I2. What do you mean by the resistance of a conductor? Define its unit. So the resistance of a conductor is a property of the conductor which affects the flow of current through it on maintaining a potential difference across its end. B. In an electric current, what is resistance wire and a cell of current flowing is I. So, if given resistance wire is replaced by another thicker wire of the same material and the same length, then cross-section area wire is increased, and consequently its resistance decreases, so the current flowing in the current increases. List the factor on which the resistance of a cylindrical conductor depends. So the resistance of a cylindrical conductor of a wire R is directly proportional to the length L. Second, how will the resistivity of a conductor change when its length is tripled by stretching? So, inversely, here the resistivity of the conductor remains unchanged. Why are metal good conductor of electricity whereas glass is a bad conductor of electricity? Answer. Metal are good conductor of electricity because they have a large number of free electrons, thus conduction of charge is not easily possible in glass, and so glass is a bad conductor of electricity. An electrical lamp of resistance 220 ohm and a conductor of resistance 4 ohm are connected to a 6-watt battery as shown in the circuit. Calculate the total resistance of the circuit, B current of the circuit and the potential difference across the electric lamp and the conductor. So here voltage of battery V equals to 6 volt, resistance of electric lamp equals to 20 ohm and resistance of the conductor is 4 ohm. Since R1 and R2 are connected in series, the total resistance of the circuit is R1 plus R2 equals to 2 plus 4 equals to 24. The current through the circuit I equals to V upon R equals to 6 upon 24. So it gives 0.25 ohm. Experimentally proved that in series combination of three resistance, a current flowing through each resistance is same. So plug the key and note the ammeter reading, then change the position of ammeter to anywhere in between the resistor and again note the ammeter reading. We find that ammeter reading remains unchanged. It shows that in series arrangement same current flow through each resistor. B. Total potential difference is equal to the sum of potential difference across individual resistor. Insert a voltmeter across the end X and Y of the series combination of resistor. Plug the key so as to complete the circuit and note the voltmeter reading V across the series combination of resistor. Three resistors of resistance R1, R2 and R3 are connected in series and parallel. Write expression for the resistance of the combination in each case. So in series arrangement, equivalent resistance of Rs equals to R1 plus R2 plus R3. In parallel resistance arrangement is equals to Rp is given as Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Be here R1 equals to R2, that is 12 ohm, and volt equals to 3 volt. For minimum resistance, two resistors must be connected in parallel so that R1 upon R1 plus 1 upon R2 equals to 6 ohm by putting value. For maximum resistance, two resistors must be connected in series so that Rs equals to R1 plus R2 equals to 12 plus 12, 24. A wire of resistance 8 ohm is bent in the form of a closed circle. What is the effective resistance between the point A and B at the end of diameter of the circle? So, as resistance of entire wire bent in the form of a circle is 8 ohm, hence resistance of each half part will be 8 by 2, that is 4 ohm. Now these two resistance of 4 ohm are joined in parallel between point A and point B. Hence, effective resistance of the circuit R is given as 1 upon R equals to 1 upon 4 plus 1 upon 4 equals to 1 by 2. So the resistance is 2 ohm. The ammeter reading equals to current flowing in the circuit, which is 1 ampere. Establish the relationship between define the equivalent resistance of a combination of three resistors having resistance 1, 2 and 3 connected in parallel. In parallel combination of three resistors is R1, R2 and R3. The current in each of the resistance is different. If I is the current drawn from the cell, then it divides into branches I1, I2 and I3. Thus I equals to current 1 plus current 2 plus current 3. Thus from Ohm's law, I1 equals to V by R1, I2 equals to V by R2, and I3 equals to V by R3. So I equals to VR. So putting the values, we get V upon R equals to V upon R1 plus V upon R2 plus V upon R3. So this implies that 1 upon R1 equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. What is meant by an electric current? Name and define its SI unit. In a conductor, electrons are flowing from point B to A. What is the direction of the conventional current? Electric current is defined as the rate of flow of electric charge through a cross section of a conductor. If Q charge passes through a section of conductor in time t, then the current equals to Q by T. SI unit of electric current is ampere. Current is said to be 1 ampere if the rate of flow of electric charge through a cross section of a conductor to be 1 coulomb per second. Direction of conventional current is taken as the direction of flow of positive charge or opposite to the charge of flow of negative charge. If negatively charged in a conductor flow from B to A, then direction of conventional current will be from A to B. Here current I equals to 1 ohm, time equals to 1 s, and charged on electron E equals to 1.6 into 10 power 9 minus 90. Define electric resistance of a conductor. So electric resistance of a conductor may be considered as a measure of the opposition offered by the flow of electric charge through it. List two factors on which resistance of a conductor depends. So at the given temperature, resistor of a conductor depends on its length, cross section, nature of the material of the conductor. It is found that R is proportional to L, whereas R is inversely proportional to area. Where P is a constant known as resistivity of the material of conductor, its value depends only on the nature of the material of the conductor and the temperature, and is interdependent on the dimension. State Ohm law. So according to Ohm law, physical conditions like temperature remain constant. The current passing through a conductor is directly proportional to the potential difference maintained across the end of the conductor, i.e. V is directly proportional to I, or V equals to IR. Here R is known as resistance of a given conductor. It is a constant. It is a property of the conductor which affects the flow of current for a given conductor. Value of resistance R is a constant at a given temperature. As rating of bulb is 220 volt 100 watt, hence P equals to V1 and equals to V square by R. Putting the value, we get the power will be 25 watt. Two identical resistors are first concentrated in series and then in parallel. Find the ratio of equivalent resistor in two cases. So let two resistors of the value R each first joined in series when equivalent resistor Rs equals to R plus R, that is 2R. On joining these very resistors in parallel, let equivalent resistor be RQ, where R 1 upon R P equals to 1 upon R plus 1 upon R, that is 2 upon R. So putting the value, we get 4 upon 1. Derive the expression from power P consumed by a device having resistance R and the potential difference V. Amount of work done in carrying a charge Q through a potential difference V is W by QV, where Q equals to IT, where I is current and T is time, as power is defined as the rate of doing work. Hence, power P equals to W by T and VIT equals to T upon T, that is VI. A torch bulb is rated 5 volt and 500 mA. Calculate its power, its resistance, the energy consumed. If the bulb is lengthened for 4 hours, here rating of a torch bulb is V equals to 5 volt and I equals to 500 mA, which is equals to 0.5 A, that is ampere. Power of torch bulb P equals to VI, that is 5 into 0.5, that gives 2.5 volt. Resistance of the torch bulb is 10 ohm. Energy consumed by bulb in 4 hours equals to power into time, so 2.5 into 4 equals to 100 watt. Why are metal good conductor of electricity whereas glass is a bad conductor of electricity? So metal are good conductor of electricity because they have a large number of free electrons. Thus conduction of charge is not easily possible in glass, and so glass is a bad conductor of electricity.